My name is Jeff Seisler. I'm the CEO of my own company, Clean Fuels Consulting, located in Brussels, but also in Washington, D.C. And I've been asked by Russian consultants to help out and moderate today for this panel on green mobility and the new economic model. There have been some changes in the program, so I just wanted, some of this is still correct. One individual, Arnie Richters, has not been able to come but has made a statement, which I'll read a little bit later on. He made a very interesting input to the workshop. Our players today, Vincent Cadet from electric car sales and marketing from Renault, so we have an OEM, original equipment manufacturer. We have William Tomboy from the battery industry, Paul Tedien, General Director of iTrans, and then the replacement for Mr. Richters is Paul Neuenhaus, who's the Center for Automotive Industry Research in Cardiff University. I want to start off by giving you a fairly quick run through some ideas about commercialization. I've been working on commercialization activities for about 30 years in alternative fuels, mostly with natural gas vehicles. However, it doesn't matter what the fuel is, this process of trying to get into the marketplace is all the same. And we're talking a little bit about chickens and eggs, so we're going to talk a little bit about breakfast, chickens and eggs. And when you have ham and eggs or bacon and eggs, then we have another situation, because there we look at that and you say, well, the chicken is involved in breakfast, but the pig is committed to breakfast, okay? And that's what we want to talk about in this session, involvement and commitment. So I want to run through some things fairly quickly. Why are we interested in so-called green transport? Well, it's fairly straightforward. Energy security, a little less reliant on oil, environmental improvement, despite the fact that the car manufacturers have done a fantastic job in making cleaner gasoline and diesel vehicles. As good as their technology gets, if you put better fuels into them or cleaner fuels, they get even better. So environmental is an issue, air quality as well as climate change, reduced energy consumption in terms of efficiency, and we want to try to make this economically competitive, and that's the key to all of this. Who are we talking about, or what are we exactly talking about when we talk about alternative fuels? This is what's on the menu. We've got liquid biofuels, ethanol as an additive to gasoline, biodiesel in part or completely substitute. Then you've got the gaseous fuels. There are 3 of those. Liquefied petroleum gas, which is a mixture of propane and butane, which on the hydrocarbon scale is slightly below methane, which is slightly below hydrogen. So we're talking in terms of the gaseous fuels, the top of the hydrocarbon chain. Methane, CH4, comes as fossil fuel, the old molecule. It can be renewable based on garbage or agricultural waste, something that here in Lille, there's 125 buses running on natural gas made from garbage in the city. And then you have liquefied natural gas. When you drop the temperature of methane to minus 163, it liquefies, so it's more dense. Then you have electricity, various hybrid strategies, and we have our electric plug-in batteries, vehicles. Just to set the record straight, there are no fuel panaceas, okay? Every fuel has its benefits and every fuel has its challenges. The cost is an issue. The environmental quality will be different in each one. Energy availability will be different. The availability of vehicle technologies, all of these things are what's going to make or break the market in one kind of way for each of these fuels. But for me, as an advocate for the past 30 years for mostly natural gas vehicles, but involved with hydrogen and electric as well, the critical challenge is for the industry and policymakers is to find that right balance of what kind of fuels we're going to use, because we have to recognize gasoline and diesel and internal combustion engines are going to be here for a very, very long time, and that's fine. But we need to see what the balance is going to be. Now, the fuels, I call it the fuel du jour, but the fuel per decade kind of has changed amongst policymakers. In the 80s, big favorite was electricity. Then we switched into the fuel cell mania in the 1990s. The early 2000s, all of a sudden, the sex appeal changed to liquid biofuels. Now we have sustainability issues and other things with that. And then hybrids came in. The Prius was introduced in Japan in 1997, and then in 2000, 2003, it became sort of a worldwide more vehicle. And that kind of drove the interest in hybrids. And then now, since about 2008, we're back to the electrics. So this has changed quite a lot, and we're still asking for every alternative fuel. To one degree or another, we have to solve this chicken and egg. Which comes first, the vehicles or the fueling station, or in this case, the recharging station? And the answer is they've got to come simultaneously. Now, the other two things that are similar about all these alternative fuels is the first cost of all the vehicles are higher, maybe with the exception of a fuel-flexible vehicle running on percentages of ethanol. And range is an issue on each one of these alternative fuels. And we're talking, in this case, energy storage for electric vehicles. The success factors are all the same for all the fuels. The government, I've only known 1 or 2 countries where alternative fuels have been successful without government support. Almost every single country is going to need support from the government in one form or another, and there are lots of forms. The energy industry, natural gas vehicle industry, the gas industry, and the oil and gas industry support. The electric industry is going to support, we hope, electric vehicles. The hydrogen industry, for fuel cells, there is no hydrogen industry. Not, as we know, the electric and gas industry, and that's going to be a challenge for the fuel cell cars. The hydrogen industry right now is very much a commercial industry with about 500 kilometers of pipeline in Europe. So that's another story for another conference. The farm industry is supporting liquid biofuels. So the energy support, or the champions, have got to be there to supply the energy. The availability of the vehicles, real, not implied. We get the OEM involved, or are they committed? You're going to hear from, I think, Renault that they're committed. There are a lot of other ones who are just sort of involved, and that's going to be an issue for the success in the marketplace. Favorable economics, and we're talking about 2 things. We're talking about the cost of the vehicle, like I said, which are mostly higher, and we're talking about the cost of fuel, which in the case of alternative fuels, liquefied petroleum gas, LPG, and natural gas are about the only 2 that are actually cheaper than petrol and diesel. Electricity can also be cheaper than electricity and diesel, diesel and petrol. It just depends on how it's priced at the recharger. So those are the things that are going to make or break the market. And all of this has to do with whether or not this is going to take place. This market is like a 3-legged stool. You've got customer demand has to be there. You have to have a fueling infrastructure, and then you have to have vehicles. And of course, as I said before, the government touches each one of these areas to incentivize, de-incentivize, develop standards, non-financial incentives, et cetera. But the heart of whether these things are going to be successful comes right down to the fuel price of diesel and petrol. What the new technologies on diesel and petrol are going to be that are produced by the car manufacturers and the truck manufacturers, and what kind of new and cleaner diesel and petrol fuels. So everything depends upon what goes on gasoline and diesel. When the price of gasoline drops below $100 a barrel, alternative fuels are not so competitive. When they're 100 to 120 and more, alternative fuels are very competitive. Now, challenge of commercializing new technology, particularly electric vehicles, which are a paradigm change for the industry that's producing internal combustion engines. Anytime you have an infrastructure involved with commercializing a new technology, it's going to take 35 to 55 years to penetrate 25% of the market, which is a pretty good share. However, if you look at the automobile, from 1885, 25% of the market took 55 years. The telephone, household electricity. Okay, when you get into computers, you don't need an infrastructure. It was pretty quick. The cell phone was very quick, even with a small infrastructure. They kind of broke that rule. But the message is here, this stuff takes a long time to get into the market. And in terms of commercialization, from going from the initial concept, research, development, demonstration, field test, lots of technologies make it up to here, and then boom, go into what I call the chasm of commercialization. And it's going to take as much money, or twice or three or four times as much money as it took to get from here to leap over to there. Okay? And a lot of people in the technology business have no clue when they're here of what's going to happen when you get there. And even companies that can leap over there, sometimes they're teetering back and forth and don't have enough traction. They may have some financial horsepower, but they may not have the traction to make it this far. I think Better Place is kind of an example of something that leapt and then boom, fell back. So this is what we're facing in that. The European Commission has put together, finally, an alternative fuels policy. When I was the executive director of the European Natural Gas Vehicle Association, we started in 1994. In 1995, we advocated the first European alternative fuels policy. 20 years later, they finally looks like they're getting with the program, because they have now, apart from a lot of other really good things they've done in 20 years, demonstration programs, support for research, a lot of really good things, but it's been very eclectic. So we now have proposals 2013 on fuel station targets, the clean power for transportation. Now, where are we with, this is the most recent thing I could find for electric vehicles from the International Energy Agency, and our colleague from Renault said that I was not accurate in some of these numbers, but okay. I didn't get any new numbers from you, Vincent, so I'm using the old stuff. But the idea is here, look, we've got thousands of units. We need millions of units. And if you look in some of these countries, I mean, we're talking down here, you know, in the singles of 1, 2, 3, 4, 5,000. And we really need to build the sustainable market. We're going to have better numbers. And will there be sufficient critical mass of EVs to support this ambitious infrastructure that's been proposed? Is there going to be sufficient demand to drive the OEMs to keep moving forward with these EVs? The vehicle manufacturers have always told me we need 5,000 vehicles a year for 5 years, up to 25,000 vehicles, sustainable, and that's the number we need to grow. Maybe Vincent will help us out with that as a car manufacturer. Now, we also have CO2 credits that have been proposed. I personally like these credits. I would have liked to have seen them at 95 grams per kilometer. The environmentalists hate this stuff. They think it's a loophole. I don't agree with that. I think the car manufacturers, to develop cars that run on different fuels than they're used to, require some incentivization. So I think incentives are very, very important, and I just wish these things were a lot stronger and for a lot longer. But I like to get the view of the other people. So policies have to have not just sticks, but they really do need carrots. And the kind of numbers we're talking about here, the electric vehicles put in place a critical mass of charging points so the companies will mass produce cars. 7.2 million private and 800,000 public charging points. Those are the kinds of numbers that the Commission has so-called mandated. We'll see if these survive Parliament, which is going on right now. The cost is 4 to 8 billion euros. It's really not a lot of money. Actually, you think about other money that's spent on other things in public policy, or even in the commercial marketplace. You know, worldwide, we're spending 2 billion euros a year just buying candy, okay? So these numbers are not really big numbers, okay? But the question is, who's going to pay for it? The Commission says not the public sector, okay? If not the public sector, is the private sector investment alone? Is that going to achieve these targets without financial incentives? The historic evidence suggests that the way to do this, as we heard this morning, public-private partnerships. Some of the best programs I've ever seen developing alternative fuels have been done with all the stakeholders involved. And I can give lots of examples at other times, but that's not the point of this. But the point is, public-private partnerships, the 3 Ps, absolutely the best way to go. Engagement of the traditional European fuel suppliers. It's a little bit different with electric vehicles because electric, you don't get served petrol and diesel. For the other fuels, you have to go into the fueling station. But can the private sector residential fueling market be mobilized and incentivized so we can get electric vehicles on the road? So the policy that we've got right now, as I showed you, just sort of the numbers in brief, the timing, well, the Commission wants all these things done by 2020. Having spent 30 years doing this kind of stuff, it's not going to happen by 2020. Those numbers are good numbers based upon good research, based upon very smart thinking at the Commission. I support the numbers that they've used. We were part of sort of that development stage. But is it better maybe to go to 2020, 2025, and 30, phase these things in? Or is more transition time going to be needed? Because just to develop standards and regulations is a very long process, and that really, really makes it much more complicated. Talking about harmonization for electric vehicles, plugs, low voltage, high voltage, smart metering, vehicle-to-grid interface, fuel station signage, all of these are parts of the bits and pieces of the regulatory framework that have got to be developed if the vehicles are going to be successful in a long-term sustainable way. My own experience with signage, just as a small thing, a really small thing, we were asked by the German stakeholders for natural gas vehicles to start getting signage with the United Nations so that when you put a fueling station out, people can see, oh, look, I can get to a natural gas or LNG station. So we got, in 3 years, it took to get CNG, LNG. We had different artwork, and it's a long story, but yeah, it's a long time. So we were successful in getting for CNG and LNG. The LPG people followed me along, and the hydrogen people followed us along. So we had this now, network of signage that we can go internationally under the UN treaties. Come electric vehicles. Well, the WP won, the Working Party won. These guys are, lawyers and civic engineers, and they're trying to make decisions about signage. And they had some really nice artwork. The French artwork came in, and the Danish put it in, the Swedes. So in the infinite wisdom of the group trying to harmonize one sign, they couldn't. So they ended up with 6 signs. So right now, in the international framework, which is totally different than anything else in any other signs in any other part of any other industry, the electric vehicle industry now has 6 different approved signs by the United Nations. Okay, so that's just an example of these things. Now, the comprehensive alternative fuels policy is very, very important. We've got this, but what we really want is that. So that's what we're here to talk about today. Some chickens and eggs, some focus on the road ahead. The key is that both government and the private industry have to make good, smart, strategic decisions about how we want to get from where we are today to where we want to be tomorrow. So that's my overview. We haven't sort of decided on who's our next up at bat, but I think Vincent, you're first on the list. Let's go with Renault, and we'll hear from the so-called horse's mouth. This is the man who, if this industry isn't behind it, then it doesn't happen at all.
Hello, everybody. I can tell you one thing, we're in the right room today, because it's always when we speak about EVs that we have some very nice debates and discussions, because the subject is full of passion, of course, for everybody. So I will try to introduce very quickly the world of Renault and EV, and of course it will give us a lot of space for questions and debates. So I'm extremely lucky to be in charge of sales, marketing, and battery business for Renault, for all EV and worldwide. So I can see very different markets and issues. And I can see every day that the planet, all the countries of the planet are not equal to EV, unfortunately. So the first thing I would like to say today is that the revolution has already started in terms of EV. That means EV is not something for the future, EV is something for now. The only problem we have is that the people who could buy an EV today don't know EV. And this is maybe the main problem we get. So just to give you some data, Renault and Nissan, are sister companies. We have a common EV strategy. We did not make exactly the things in the same order, but the strategy is common. We are the first automaker to launch 4 EV cars. That means a full range with different sizes of cars. On the left, you got Twizy, which is a 2 places, very funny car, in which we take a terrible, fantastic benefit in terms of image, because it's a car, you put this car in the street somewhere and you get immediately 10 people around it. It's an expensive car, so we don't sell a lot, but we use it as a a driver, an introduction to the EV world for our customers. Zoe in the middle is the first, I would say, no compromise, affordable EV car. This is, for me, the start of the EV revolution in the world. Fluence is a sedan car, mainly for emerging markets or for sedan market, Asia, South America. It's not a car designed for Europe. We sell it in Europe. We made business with a lot of early adopters with it, but it's not a car designed for Europe. And the fourth one, the first EV LCV, Kangoo, which is a big success in Europe today, is a real LCV EV car and works very well in Europe. So 35,000 cars sold in the world today. One EV out of two in Europe is a Renault. And if you add Nissan, we have today 80% market share in Europe on EV market. So why should you buy a zero-emission vehicle? So very quickly. Because it's cheap. It's not cheap for everybody. It's cheap for people driving more than 7,000 kilometers a year, usually. And it depends on country because tax incentive is order one. That means if you get a tax incentive, you can have an EV much cheaper than an ICE car. If you don't have, it's much difficult. It's a real pleasure to drive an EV, and maybe this is the thing that the people don't know. If you don't have driven a Zoe or a Leaf, you cannot imagine the pleasure which is to drive these cars. Pleasure because it's comfortable, it's totally silent. When you joke about EV, we say all this marvelous driving sensation, comfort and silence that all the engineers of Rolls-Royce have tried to put in ICE cars during 50 years, you get it on a Zoe or you get it on a Leaf. And this is a terrible, fantastic driving experience that you can find only on an EV. When you've driven an EV during 2 or 3 months, it's very difficult to come back to a normal car. Today we get some good ranges. This is the homologated one, 200 kilometers. The real one is close to, I would say, 150 kilometers, and we will come back on this point after. Of course, you get in many countries additional benefits. You have free parking in a lot of cities in Europe. You don't pay tax if you enter in London with an EV. In Amsterdam, you get free parking and you can get a free charging spot. There are a lot of incentives. In Paris, it's free parking. A lot of incentive additional to the EV. And for, of course, these are zero-emission vehicles, and we are convinced that this is the only way to reconcile people and automotive in the long term. Because today we, from our generation, we live all the day with a terrible paradox, which is we use normal cars, we use ICE cars, we reject CO2, we reject the NOx in the atmosphere, and at the same time we take pleasure to drive these cars. And the car is more linked to liberty, to pleasure of driving, than to pollution. Things are going to change, because there are new generations coming, and for this generation, car is not anymore a pleasure object. It's a constraint, it's a cost, and it's a dirty thing. And if you doubt it, discuss with your children and grandchildren, and you see what they think about cars. And new generation don't want to own and to drive dirty cars. So if you put a little long term in the equation, you see that this is the only way to reconcile car and people. So this is the most important for us on the sales point of view. It's very pragmatic. You got on the left, it's Europe, the daily trips. You see that 87% of daily trips are less than 60 kilometers per day. And on the right, you see the B-segment cars, and you see that 32% of customers, that just make 1 million customers per year in Europe, never drive journeys more than 150 kilometers, which is exactly the range, the autonomy of a Zoe, for example. So our problem today is clear. We got 1 million customers ready for EV. We can buy an EV without any compromise, except that they don't know EVs, except that they are very afraid of EVs. They got the range anxiety of the cars, and we have a lot of education, pedagogy to put in place to convince these customers. And this is our main target today. Just a quick zoom on Zoe. So Zoe, I would say, is the first EV car without any compromise, except it's an EV. So it's a B-segment car. It's a Clio, it's a Corsa, it's a Fiesta, as you want. No compromise with a very big trunk, so no change, no impact on EV on the way you use the car. Best level Euro NCAP, 5 seats, 5-year warranty, full equipment. It's a normal car, except it's an EV. So no compromise when you buy it. it has a real, so in EVs and in Renault, we made the choice never to speak about homologated range because it's a lie, clearly. So we speak always of real range, and we explain. So in the worst conditions, that means in winter, when you use heat system, when you drive not very economically, you can have at minimum 100 kilometer range. And if you drive in normal conditions, you can have, in temperate conditions, you can have 150 kilometers. If you drive on an eco way, you can go to 200 kilometers. I do it every day. And you will see that when you drive an EV, you see the range, you see the consumption, and you are pushed to save the energy, which is very different from an ICE cars where you don't see if you consume or not. You just see it when you pay your gas. So this is something very important. What about the future? Maybe Willy will speak a little about batteries, but once the cars are in the street, what we see it as the battery technology is developing much, much quicker than expected. And at the beginning of the EV adventure of Renault, we thought that it would not be possible to get good ranges before 2025, 2030. In fact, it will go much, much quicker than this. And we will be very close in terms of autonomy between ICE and EV cars in 2020. And this, few people have it in mind. So today we start with cars with 150 kilometers range, which already fit with 1 million customers. I would say within 5 years, we would fit maybe 80% of B-segment customers' usages. Just to zoom on Zoe, which allows also a little to speak about infrastructure, which is today a main problem. So Zoe has a very innovative charger, so it can charge in 3 ways. At home with normal wall box in 6-9 hours. In accelerated charge, so 22 kilowatt, 1 hour. Or in fast charge, in less than 30 minutes for 80% of charge, which is 43 kilowatt. So you can do everything with the Zoe. All EV cars don't have this full possibility, but it's the case with the Zoe. Everywhere you go to charge, you can charge with the maximum possibility of a charging point. Infrastructure is today maybe the biggest problem we have, because even if the customers maybe at 90% of our usage do not need infrastructure, infrastructure is the most reassuring point, and it's the biggest sales blocker we have for EVs. Because people got the range anxiety, so they always think, and if I need to make today, by miracle, 200 kilometers, how will I charge? Practically, we have sold 35,000 cars, EV cars in Europe. Our customers, they charge at home or they charge at work, and always. But they need a safety net, a safety infranet to be reinsured. This is for today. Tomorrow, in 5, 6, 7 years, when we'll get higher ranges for EV cars, of course, people would like to use it as normal cars. And they will need some infrastructure to extend their range and autonomy and to use their car without any constraints. But today, infrastructure is most reassuring than useful. Just to finish on Zoe, Zoe is also a very connected car. So with a kind of iPad in the cars where you can manage all your charge. So the charge is also, you can manage your charge with your mobile phone. That means you have a small application. And you can decide when your car is charging or not. You can decide to put the heat at a certain time so that the car is heating in the morning while it's charging, so you don't consume the battery. So it's a very smart car also. Maybe just to conclude, I will speak a little about market because we are speaking about it. The real EV cars, Zoe, Leaf, Kangoo, were launched globally in 2012. Okay, so it's a very recent history. Globally, the worldwide market of EVs, it's close to 100,000 cars per year today, and it's multiplied by 2 or 3 each year. Okay, so on one end, it's not very quick. Volumes are still limited. On the other hand, when you compare the start of EV with the start of hybrid, if you come back in '98, when they launched Prius, you see that EV is starting maybe 10 times, 20 times quicker than hybrid on the same period. So it's kind of empty glass or not. On one end, it's starting very well compared to hybrid. On the other hand, it's starting quite slow. But all the weak signals are okay for us. We have an incredibly high rate of satisfaction for the cars. We are 98% of satisfaction. And we have a recommendation rate from our customer of 97%. That means each EV customer today who drives a Zoe or a Leaf or a Kangoo is telling to all his friends, to all his family that he drives a wonderful car and that they can access to this wonderful car. So this is for us a very important weak signals that we look and we discuss with the customers to push the market. As long as these weak signals are okay, as long as this infrastructure is developing, and this is the case, even if it's slower than expected, as long as the autonomy of batteries will increase at high speed like it is today, I think we can be very optimistic for the future. Thank you.
Our next speaker is Willie Tomboy, Director of the Industrial Battery Working Group, Recharge. And we've just heard that if we have a good battery, then there's no stopping this technology. So that's the question. Willie?
Good afternoon. Thanks for showing up. Compared with the number of people this morning, it's a small group. It's a little bit disappointing to see such a small group on green mobility. I was also a little bit disappointed this morning to not to notice anything about green mobility in this morning's discussion. We talked a lot about technology, but not about new technology. And when you think about this region, where a lot of industries are located with regard to automotive, I didn't hear a lot about new technologies. And I mean new technologies with regard to hybrid, plug-in hybrid and electric vehicles. I think that is one of the big challenges and the big concerns of the industry in Europe. It's that the technology and the innovation on electrification of road transport is not in Europe, but is in other parts of the world. And the link with European industry is not there yet. So I think this is one of the major challenges. Some of the other issues here I want to briefly bring to the group here for discussion maybe. European transport policy, infrastructure is already being discussed. Consumer take-up, of course, the market. Then, of course, the development of new batteries. Resource efficiency, because this is a big issue. The raw materials initiative of the EU, rare metals, recycling, extension of the product life cycle, reuse and second use, I will come back to that. Transport regulation with regard to batteries for electromobility. And then a number of legal considerations, because we all have to deal with regulations. I don't need to say that advanced rechargeable batteries you will find now in most of new modern applications, but there is this global competition, and at this moment basically Europe is out of the game for the moment. So if you look at car industry, internal combustion engine in Europe, diesel technology, gasoline technology, but electromobility technology, where is it? I think this is one. But Europe is striving towards what they call this circular economy, closing the loop economy. And I think one of the aims should be to try to bring production of batteries for electromobility production and development, cathode, anode development and cell development for batteries and electric motors into Europe. And this is missing today. So maybe an opportunity for local investors in this region. European sustainable transport policy. What I just said, this is part of the game. There was a program from 2009 to 2013. Maybe some of you are knowledgeable about that, about the Green Cars Initiative. There is a new framework program, Horizon 2020, goes 2014-2020, but they are thinking towards 2030. And they have a European Green Vehicles Initiative Association created to provide funding based on calls for industry in the public-private partnership programs to do not only research and development and innovation, but towards deployment. And I think this is the difference between both is deployment. They want, rather than innovation and research, to really deploy industrial activity for electromobility in Europe. So I think an opportunity for European industry. Some years ago, when I was in the automotive sector, I made an attempt to combine all what car companies and governments have said about how many hybrids and plug-in hybrids and electric vehicles will be on the market by 2020, and between 7 and 8 million on the road. And tomorrow we are 2014. Just imagine in the next 6 years whether we're going to end up with those numbers. I leave it up to you to make your own evaluation of all those perspectives. But this is important, because I mean this is also investment and opportunity for business. Infrastructure for e-mobility. I think the European Commission recognizes that the infrastructure, and Vincent also brought it, with the common standards, as Jeffrey also said, this is a key issue. Luckily, there is now, and as already mentioned, it's now in debate in the European Parliament. There is a legislative proposal for an infrastructure build-up. With some obligations and a network approach. And to give you an example, those are the minimum number of electric vehicle recharging points. And if you look at France, close to 1 million charging points in France, of which 100,000 in public areas by 2020. That's another reflection. Is that going to happen or not? I remember a few years ago about what some people said about biodiesel and ethanol stations in France. And if you compare the numbers then and the actual numbers today, so it's another reflection. Then the European transport policy. They are focusing on electrification of road transport. And there we see that batteries, all of a sudden for them, they say, oh yes, batteries, it's important because it's the engine of the electric car, together with the electric motor. So we have to take care of the battery. Okay. So they say investments are needed because for a battery you need raw materials, battery dependency, and also we talk about recycling. Recycling opportunities and even reuse, but I'll come back to that. The development of lithium-ion batteries, because now in electric vehicles you see a movement towards lithium-ion batteries. In the past, well, currently still in the hybrid vehicles, mainly nickel-metal hydride batteries, but now you see the move towards lithium-ion batteries. So a lot is to do about lithium-type chemistries, different chemistries, so that also makes it more complex, different chemistries. And you see the development of lithium-ion batteries from the small mobile phones, laptops, up to the big EV batteries, combined with a very specific battery management system, which is developed to manage the system of that battery for a particular vehicle, for a particular application. It's important to realize that with regard to reuse or second use. Some examples of large industrial batteries. This is from Saft. It's a big stationary battery. Saft is a big French company specialized in big battery packs for the military, for stationary applications, for business, for military, hospitals, etc. And then electromobility. This is a Toyota battery from a plug-in hybrid. And this is the T battery for the GM Volt or the Opel Ampera. By the way, this one weighs 450 kilograms. Naked like that. Not if you pack it for transport, and it weighs maybe more than half a ton. What I wanted to say about that, if I can go back, this is very different from the small consumer batteries, also lithium-ion batteries. So with regard to the weight and the chemical composition, we are talking about small chemical factories here. So this is something to take into account. Until now, lithium-ion batteries have been dominated by nickel and cobalt chemistries. So rather valuable materials. In the future, they're going to go to other chemistries with less valuable materials, which is going to give an economic issue at the end of the line, at the end of the product life cycle with regard to recycling. I'll come back to that. A small word on reuse of the battery. Reuse is when the battery is used after refurbishment or remanufacturing or repurposing for the same application as it was initially designed for. So reuse is defined in the Waste Framework Directive, reuse. So we call reuse for the same application. And the issue is with the extended producer responsibility. If it stays within the same producer, then you cover your producer responsibility. Because producer responsibility you have until the end of life stage for the full value chain as a producer putting a product on the market in Europe. When it comes to second use, means you for a different purpose, then it's a different ball game. Unless the second use is made by the first producer putting it on the market. And on top of that, second use is not defined in any of the waste framework regulations. It's not defined at all in European legislation. But people kind of mix those terminologies. With regard to second use, you have the technical and regulatory issues. You have the battery management system. If you use the battery for something else, then you hear sometimes talk about we use the battery of the car for a home stationary application. It's not that easy. It's not that easy. Because you also have a different management system. And you have the UN model regulation, which says if you for transport of dangerous goods, that you have to meet specific testing requirements. So if you put a battery as a new application in the market, in fact, you have to deal with UN regulation and you have to go to the testing procedure. I'm not sure whether everybody realizes that. Therefore, to me, a very good example and a little bit out of the box is the business model from Renault, where, as Vincent was explaining, they sell their electric vehicle, but the battery is not sold. The battery is leased. So the battery stays ownership of Renault. So at end of life, usually end of life happens in Europe, the average between 13 and 14 years is the average. So you sell a car in the year 2020, by 2034, 35, the battery will come at end of life. But in case of warranty or in case of accident or whatever, the battery goes back to Renault and they decide whether the whole battery or part of the battery, a stack of the model, will be changed. And what is not functioning anymore will go to recycling. So they keep control of the full value chain. And I think this is from an innovative business model. I think this is a very good idea. And I'm sure other car manufacturers are thinking the same way towards the future, or they will, if they haven't done so far. As I said, transport regulation for lithium-ion batteries is very complicated. With regard to news defective for end of life, I'm not going to go into details with that. A few considerations. They talked about the recycling of lithium-ion batteries. It's purely economic because the process to recycle lithium-ion batteries in Europe is in place. There is no issue with regard to recycling lithium-ion batteries. It can be done, capacity is there. But they need to take into account the complexities of the new chemistries. And my last slide is that the current recycling cost, because of the lower value, as I explained, of the new materials put in those lithium-ion batteries, will have a significant impact on end-of-life management of the battery. Big batteries, huge transportation logistics cost, because there are big batteries, less value of materials. Maybe the volume, scale volume, as of the year 2020, because I think EVs will take up as of 2020. Will that be enough to change the economic impact of the recycling of those batteries? So we believe that it's more advisable, rather than giving targets on recycling efficiency of batteries, to have more targets and on the quality of the recycled material, so that the recycled material, part of the raw materials initiative and resource efficiency, that the recycled material is being reintroduced in the industrial processes in Europe for electromobility, rather than on the quality of the recycling process. There are some very good recyclers also in France, very good recyclers in France, that can do this. Okay, thank you very much.
Okay, so that's the other piece of the car, which is not in control necessarily of the car manufacturers, but it's absolutely critical. We're going to just jigger the schedule here. Paul Neuenhuis from the Center for Automotive Industry is going to give a brief presentation, and then we're going to have the other Paul Tadian, will come right after him, and then we'll open it up for questions and discussion.
Thank you, Mr. Chairman. Just briefly, I'm not a technologist. Our Electric Vehicle Centre of Excellence at Cardiff University is a joint venture between the business school, where I am based. I run the Centre for Automotive Industry Research. We are more interested in what things cost. The other part of the joint venture is our School of Engineering. They understand the technology. So they tell us about the technology and we work out how much it costs. And cost is, of course, a key element, really, in this whole picture. Right. What we've seen recently, and we saw the presentation from Renault earlier on, I'll pick up some figures from Renault, a remarkable transformation. 5 years ago, EV was a future technology, and we now know that there are, in fact, quite a few electric vehicles on the road. And here's sort of a quick overview. These figures are from June this year, by which stage Renault-Nissan combined had sold about 100,000 electric vehicles worldwide, which is quite remarkable. Another thing we've seen, of course, in recent years is that some quite credible new players are emerging in this industry. And that really is a sign that this may be a new industry that we're looking at. And here's a Tesla Model S lurking in that picture. Right. However, the EV value chain is quite different from what we're used to. It is actually a different type of value chain. And therefore, you need to think in terms of a transition between the internal combustion value chain and the EV value chain. And this is not something everybody is quite twigged. For many years, the industry showed to decision makers like in government, for example, ordinary internal combustion engine vehicles that had been converted to EVs. And this sort of lulled people into the false sense of security that, oh, well, this is no problem. You just stick a battery in an electric motor and you've got an electric vehicle. But once you want to do it properly, you're dealing with a different kind of industry. And because of this, there are new risks and there is uncertainty, all affecting all players along the existing value chain. So just a simple picture of the value chain, very oversimplified. If you are, for example, a component supplier, so you suddenly have to deal with new products. If you make, for example, camshafts, will you still be in business in 30 or 40 years' time? Question. However, if you make battery technology, is the battery technology you've got what is needed? And will you be able to scale up to the demand required? And will you be able to meet the requirements of the automotive industry in terms of safety, reliability, and cost? Right. If you're an OEM, are you really going to enter this market? Well, Renault and Nissan have decided, yeah, we'll go in there. This is going to take off. But some manufacturers are just sitting back and seeing how others like Renault and Nissan are getting on, right? And then, if they're getting on all right, there will be a supply industry and they can just come in there. So there are different approaches here. Then we have the retail side of things. Now, we know from talking to Nissan that they had to put a lot of effort into training sales personnel in dealers into who to sell these cars to. Because the last thing you want is selling an EV to somebody whose use pattern it doesn't fit. Because the first thing they'll say, well, this car is quite useless. And that's not what you want with a new technology. So this is important. Then distribution and maintenance. Maintenance requirements are quite different. We know from some industrial environments where they run electric vehicles that certain types of work are just not needed on an electric vehicle. They're inherently quite reliable, but different sorts of things go wrong. Then at the other end, we've got the end user in the middle of it all. We get things like range anxiety, the additional cost and things like that. I don't always understand this cost thing. As we saw from the Renault presentation, an electric vehicle gives additional appeal. they're very quiet, smooth. They are like luxury cars, in a sense. So you're actually buying more technology. And that's also the approach that Tesla has done. Tesla says, well, what we're selling, think of a normal internal combustion car as a Microsoft system. We are selling the Apple of cars. Now, I'm an Apple user myself. I know that inherently the technology is no different, but I am prepared to pay extra for that nice shiny machine with that particular set of functionalities, right? So it is a different kind of product. Apple charges a premium. Why shouldn't an EV command a premium? Why should it cost the same? Anyway, that is something you would have to sell to the end user in the middle. At the other end, we've got a completely new set of players. These are guys that the car industry has never dealt with before. These are the electricity suppliers, electricity distribution. This is new. Similarly, these guys have never dealt with the automotive industry, and they're now beginning to find out this is really quite novel. On that side, we've got a quick overview of how that side works, because there are some interesting elements here. First of all, this sector in many countries is very heavily regulated, much more heavily than the average oil industry is. But at the other end, you get some very peculiar things. Lots of people with solar panels on their roof and things like that. Now, unless you've got an oil well in your garden and a refinery next to it, you cannot replicate this with internal combustion engines. So this is, again, a new picture. You have to deal with a new set of circumstances and probably a new set of regulations. So you need new business models, and that's really where we are doing a lot of work at the moment. Which bit of this value chain do you capture in your business model, right? This is one that, to some extent, Better Place tried to capture. A bit of energy distribution. It didn't generate anything. They had, as we know, a joint venture with vehicle suppliers to get the vehicles in there, but it didn't quite work out. Another one you could do is just stick entirely on that side. And we've already seen conflicts between people who traditionally have been on the energy side working to this business model with Better Place. In California, for example, there were conflicts in that area. Right. To finish with, a quick case study of an interesting approach to this business model issue. It's Atelier in Paris, which you may all be familiar with. The first thing to notice is a unique car. Atelier is run by the group Bolloré, who are one of the top 200 companies in the world. Still going back to the 1840s or something. There's still members of the Bolloré family involved in it. I met one of them. They started off with a battery technology. They tried to sell this battery technology to the existing car manufacturers about 10 years ago, and the car manufacturers said, no, we're not going to do electric vehicles. We're going to refine diesel, and then we're going to hydrogen. So no, we're not interested. So they said in the end, oh, well, we'll do it ourselves then. So they went to Checomp in Turin, and together with Pininfarina, developed a vehicle and built a vehicle completely dedicated to that battery technology and also to this particular application. It was actually homologated only months after they got the Autoliv contract. Because the Autoliv contract is a public-private partnership. It's local authorities in the Ile-de-France, centered on Paris. At the moment, there are 53 communities in the Ile-de-France and slightly beyond involved in it. And Paris said, our air quality is bad, we want something to do with electric vehicles, some sort of car sharing scheme, put out a tender, and Bolloré said, we can do the whole thing. One-stop shop, right? We do the vehicle technology, we manage a call center, this is important. They can make charging points, chargers. They make customer interface systems, like, for example, if you do an automatic check-in at an airport, that sort of technology they make in-house. So they have a whole range of technologies in-house that they could bring to this. And as a result of it, they could offer this one-stop shop to these local authorities. Now, when the local authorities invest 47,000 euros per location, Autoliv then starts paying for parking space. So they begin to earn money back straight away. And they, in fact, reckon that the whole thing will break even for the local authorities by next year. Right, so what they've done basically, this is their business model. They capture a very large chunk of this value chain, right? They're involved in the battery technology, so they're a component supplier. They control the vehicle and the vehicle manufacturing and design. They do distribution and maintenance through Autoleap, but you can also lease one of these cars privately. They are the end user because they run the Autoleap scheme, which is the end user to some extent, and then the users are members of the scheme. You subscribe to the scheme, and they also control some of the infrastructure, in particular the charging points. So they capture a very large chunk. However, notice the small print. They have so far invested about €1 billion in this whole project, so they'd better make it work. Another thing is that we don't know, and they don't know, where money is to be made along this value chain. And their thinking is, if we start by doing everything, after a while we can find out where the money is and then start hiving off on non-core activities. Right, in conclusion then, all existing players are at risk from this transformation that is beginning now. They will all have to decide where they're going to fit into this newly emerging value chain, which is a high-risk strategy. Regulators will also have to adapt. We've already heard about standardization issues, for example. These are different kinds of vehicles with different technologies, will need different regulations. There are new entrants coming in who have the potential to upset the equilibrium, and there will also be failures along the way. I don't know if anybody recognizes that car there. I took that picture in British Columbia in Canada. This is a Fisker Karma. This is at the moment apparently one of the failures along the way. Beautiful car, but didn't quite work. Right, thank you very much.
We're now going to go with our last presenter, the other Paul, Paul Terrien. I'm going to let you introduce yourself and the company, and then we'll go for questions.
Thank you, Jeff. Well, those first 4 presentations was extremely interesting. However, I had understood that the topic we were supposed to discuss was green mobility. Does that mean, the only response to green mobility is electric cars? I would say some of it, yes. I personally believe in electric cars. I think the question is whether electric cars, the question is not whether electric cars will take off ever. The question is when and how fast it will actually take off. However, we must not forget that a car is to go from point A to point B. Is it the only way, to use a car to go from point A to point B? I don't believe so. I don't think everyone came by car this morning. Otherwise, the A1 motorway would have been overcrowded. So I think we do need, as far as I'm concerned, green mobility is to make sure that we use the right mean of transport for what we want to do, the trip we want to make. So I won't spend much time anyway on presenting our competitiveness cluster called iTrans. I think the French government's representative this morning did mention about it and did mention that you should use it much more than you actually do today. So I will be very quick, in a couple of minutes, and in order to keep more time for the discussion and response between the audience and the presenters. So we are in the heart of Europe. There are about 300 million people in 1 hour trip by TGV. 1 hour trip by TGV, in London, Brussels, Paris, 300 million people. So we are definitely in the heart of Europe. And because we are in the heart of Europe, we believe we must be working on the future excellence in terms of mobility. Mobility for the people, mobility for the goods. So iTrans is one of the 5 official automotive competitiveness clusters in France, and which work together with the French automotive platform, which was set up recently, with the 2 major car makers and the French car makers and the major first-tier suppliers. And as a competitiveness cluster was totally committed towards collaborative innovation between academics, large companies, small companies, and also for higher education. As you know, all the European regions have to prepare what we call a smart specialization strategy. And one of the first, and actually the very first strategy activity domain, for the region of Nord-Pas-de-Calais is transport and eco-mobility. And within eco-mobility, there is definitely a launch of a big program on electric vehicles. And the objective of this region is to be the very first French region in terms of the number of electric vehicles to be used. And the regional government, the regional council is committed to install, and there is a program director in the audience, so he can confirm that, to install, first of all, 2,500 points of charge for electric vehicles in the next 2 to 3 years, I think, and up to 10,000 points of charge in the future. So there is a strong commitment toward electric vehicles. So I believe that's some kind of a carrot, and it's not a stick. It's a carrot, for the EV buyers. So as a competitiveness cluster, we are also committed to come up with a strategic plan for the next 3 to 6 years. iTrans is positioned on sustainable transport. Sustainable transport, well, what we call surface transport. That means we are not only involved with automotive applications, but also in rail application. We are the reference cluster in France for railway applications, infrastructure and rolling stock. And we are obviously also involved with automotive products, subcomponents, as we mentioned, automotive equipment. So basically, we have defined 3 strategic activity domains: transportation, systems, and services. Let's not forget that to have a big automotive market, we need a big road infrastructure, first of all. If there is no road, no need for a car. Same way for railways, obviously. And we do have cross issues which go not only from automotive application, but also for railway applications. For example, these 5 transversal, 5 cross-competitively issues which are at stake. Energy consumption. Yes, we do need to reduce the energy consumed. Well, we know the big French program on 2 liters per 100 kilometer car. We also have a similar energy consumption program for trains. Although trains, are the ones, which consume less energy. So I'm not going to go through this strategic program, just to show, we are definitely involved in this region in helping the cooperation between academics and companies to solve these technical issues. So the service we provided to iTrans members, some of them are obviously the responsibility of our clusters. Some of them are in partnership with other clusters, other organizations as well, government organization or non-profit organization, and whatever. So this is the type of support we provide to our members as a non-profit organization. We are also involved in supporting what we call structuring projects. There is one some of you may know, which is Centre d'Essai Turbo, which was a collaborative investment, private-public investment, to test turbo engines near Lille, 50 kilometers away from Lille. And the objective of, or the support of iTrans was key, you know, in getting the financial support from the public, from the local council. So we also have here Steve Security. We talked a lot about batteries, and at Ineris in Picardy, they set up a platform to test all sort of batteries to the extremes, you know, in temperatures, and so on and so on. Okay, so my question now is, we haven't talked about fifth generation road. We haven't talked much about distributed energy. We talked about shared vehicle. Let's not forget today, a vehicle, a car, is used about 5% of its life. 95% of its life, it's parked somewhere. So what will be the future vehicle? Will it be a shared vehicle? Will it be a fully owned vehicle? Will it be a fully electrical vehicle with a range extension and so on? So that's probably the time, you know, to discuss about those issues.
Okay, I had to intervene at first with a couple of clarifying questions, and it goes to Vince. You said that 7,000 kilometers per year would make it economical, make your EV economical. At what price of the electricity does that occur?
I won't speak in price of electricity, but globally in Europe today, you can fully charge an EV car between 1.5 euros and 4 euros. Okay, depending on.
Say that again, between
1.5 euros and 4 euros to charge fully 100% an EV. Okay, so it depends on price of electricity, of course. So the break-even point is between, I would say, 6,000 and 10,000 cars, depending on the country and depending on the tax incentive, of course.
Okay. Okay.
There are some countries where there's no tax incentive, where the break-even is closer to 15,000 kilometers. It depends.
Because that's going to be, I think, one of the challenges, and it was pointed out in the list of challenges, would be the price of electricity. And what's interesting about this market is that with different charging points, the traditional electric supplier is no longer in charge of setting the price. It's the guy who's installing the charging unit who's setting the price. Or in the case of a residential user, if they're just plugging in, okay, the utility company is still setting the price, but at some point the tax man's going to catch up with us and going to want some taxes from that electricity as automotive application. The other qualifying question, you said in 5 years, 80% of the B segment customers would be driving. How many customers is that B segment that we're talking about?
It's 1/3 of the European market, so it's 4 million customers per year in Europe.
So in
So
5 years...
I didn't say they will buy an EV. I would say they will be EV compatible because of the extension of the autonomy. Not the same, okay?
Okay, I misunderstood.
Not the
So,
same.
yeah,
No,
because
it's-
otherwise...
I would love it. I can tell you.
Yeah, there was a guy in the year 2000. I was at one of the European Commission events, and it was a guy from Daimler, and the fellow said, in 4 years, there are going to be 40,000 fuel cell cars on the road. And my question to him is, what are you smoking? So, okay.
I don't smoke.
You don't smoke. Good for you. Okay, in general, let's talk about the vision here. And I think we all have a view of... Paul, you said, you know, it's not a question of if, it's when and how fast. If we go to 2050, what do you all see as the balance or the mix of fuels being used in European cars? We're talking cars now, not necessarily trucks, but okay, generally speaking, in the transport sector. Do you have any feel, your success, what you've said, we have the value chain view here. What do we see as this vision in 2050 of where we're going to be? You have the microphone. Pass this along. Go ahead. Go down.
Can I ask you a question? First of all, what will be the oil price in 2050?
Let's assume the oil prices are between 120 and 150 US dollars a barrel. It's an assumption. You know, you want to be an economist, you got to assume something. So I'm assuming. What do you think the prices are going to be in 2050? Okay. Okay. That's including inflation. All right. Let's start off at the low point and let's go to the high point. What if at 150 and what if at 250?
Well, first of all, you know, we have hybrid electric. So should we mention, you know, should we consider that we plug in, your question is about plug-in hybrid and full electric, yes or no? Or do you, well, I believe, you know, for example,
Let's talk about technology.
well, I strongly believe you will have a mix of full electric and plug-in hybrid. We're talking about Europe, the European market, right? So I don't think it will be more than 50% of that, you know. We're not talking about the sales, we're talking about the park, I mean the number of cars on the road or the sales. It's not the same, you know, because so well, we have to make sure, you know, we're talking about the same figure. You're talking about the number of vehicles on the road or the number of vehicles sold in 2050, because you have a 5 to 10 years difference between the
I'm saying let's look at the numbers of vehicles, you know, generally on the road. So you're talking about 50% roughly will be somewhere between full electric and electric hybrid, which really some people would claim are gasoline vehicles. So you're still saying that quite a large number of these things are going to be running on petrol. Vince?
I would say what is showing that the world will be divided in two. There will be the electrical world and the non-electrical world. So it's true that in Europe, in Japan, in the States, there's no limit to electric cars. The only limit is the price of the batteries. So today we could take some Tesla batteries, 90 kilowatt, to put it on the biggest cars we have, and it's full electrical. The only problem is it costs 90,000 euros, but that's the only problem, but it exists. So tomorrow I can make a big LCV, I can make a big car with 100% electric, with 500 kilometers range, immediately. So it's not a problem of technology, it's a problem of price. Where will be the price of these batteries in 2050? I hope they will be very low. I hope so. So in our developed country, there's no limit. I think we will keep a mix between full electric and plug-in hybrid, because there will be an economical status on big cars and big LCV. So this is our assumption. Something between 50 and 60% in pure electric, maybe 40, 50 in plug-in hybrid. It's very difficult to say today. It's a matter of price and price versus technology. On the rest of the world, when you look at Brazil, when you look at Russia, when you look at China, the mix of, I think we will keep a mix of fossil energy. I don't know which. It's very difficult because there's a big question mark on hydrogen or not. But there will be a mix because Brazil is too much engaged in ethanol production, because habits will be very strong to disappear, and because electricity, there's a big question mark also on electricity providing in these countries. Will it be at the same level than Europe or not? It's a big question mark. This is what we assume today.
Yeah, I think for outside of Europe and for any of the emerging economies, let's call them, first they have to do is get their electric grid so you have 24 hours of electricity. Right now that's not the case in a lot of countries, so EVs don't have any room to play. Now, the question was, what's the price of batteries going to be? If we have a fantastic battery and a low-price battery, EVs will take over the world. What do you think, Willie?
I'm not so sure about that, but I think there are two aspects. One about the battery, I'll come to that. But first of all, about 15 years ago, the average CO2 grams per kilometer of cars sold in Europe was close to 200 grams. The regulator has put a ceiling at 95 grams of CO2 by 2020. And if car companies don't meet it, there will be a penalty per gram over 95 grams. It's near on the wall to go down to between 67 and 74 grams by 2025. We have discussed scenarios to go to zero emission vehicles by 2050. So zero emissions would mean cars in the use phase of going below 30 grams of CO2. So when you come to that type of technology, I don't think internal combustion engines have a chance by 2050. So I don't think there's going to be internal combustion engines by 2050. That's one stance. Other stance about batteries, yes, indeed, battery technology, but I see battery technology developing in some kind of a modularity. 100 years ago, you could buy one type of car with one engine, and maybe usually only one color. But then you had in the same car, you could have a 1 liter engine, a 1.2, a 1.5, a 1.6, a 2 liter engine. I think in the future, that will also be the case with batteries. Depending on the customer need, you will fit a battery. It doesn't make sense to put a 450 kilogram battery in your car with a drive range for 400 miles or something like that if you only need it to go into the city back and forth. So depending on the need, and Didier Leroy this morning showed this possible roadmap from small to large vehicles. I think that type of modularity will come in the years to come. So with regard to batteries, of course, there is quite a lot of advanced technology being introduced. I'm a little bit afraid that many people talk about battery technology. Yes, we go now from lithium-ion, we go to lithium-air, and in 15 years from now, when it's being pushed. So I think now companies have to do, and Renault is doing, and this is for me a very good example. So more companies gonna have to do, let's say, to be ready with the infrastructure by 2050. It's like an integrated process, and I think by 2020, I think electromobility will start off, but by 2050, I'm not sure whether there will still be internal combustion engines.
Well, that's pretty provocative. I think if you talk to the rest of the non-electric automobile industry and you talk to the oil industry, both of whom have spent multi-billions of euros, yen, dollars, et cetera, and are still building pipelines, to think that all that investment is going to go away because electric vehicles show up, like I say, it's very provocative. I'm not going to ask you what you're smoking, but that's okay. Paul?
I think if there are going to be any internal combustion engine vehicles left by 2050, they will be hybridized. They will probably be plug-in hybrids. There are various reasons for that. One of them is the efficiency, of course, to meet the CO2 requirements, but it's also the drive quality. If you've driven a Volt or an Ampera, you know that you're driving a car that's, although it's based on an Astra platform, feels much more like a luxury car. And I think people will take to that driving experience. What I'm not sure of is the availability of various key materials that we need to make all these batteries and all these electric vehicle powertrains. That's what I'm less sure on. And that would be a limiting factor on how many we can produce. That doesn't mean that it's a limiting factor on how many we use. We may just have to make them last much longer, which is a good thing anyway, which will affect these guys, of course, because their whole business model is based on flogging us new cars rather than keeping existing cars on the road. As an owner of a 40-year-old car, I know from experience it is quite possible to make cars last if you really want to. And I think that is, again, part of the business model. We'll have to think in those sort of terms rather than flogging new cars.
Okay, I have one more question, but before we do, how about from the audience? Are there any burning questions that you've got out there? Yes, sir.
Thank you. Simon Warburton, journalist with Just Auto in the UK. How would the panel convince a possibly sceptical consumer who says, well, there's no free lunch here? What is the actual well-to-wheel cost of EVs, and should that be discussed a little bit more?
Your question is about the cost of the car, that's it? Well, it depends if you take entry ticket or not, because of course you know that, for example, we got $4 billion entry ticket in the Alliance Renault Nissan for the cars. But if you get out of and without betraying secrets, it's very close. It's very if you exclude the battery, I exclude the battery. Okay, if you take the car, the pure car, it's very close. And the battery, you have two ways to see the battery. You can see the battery as part of the car, which I think is the wrong way, or you can see the battery as a part of your fuel. Okay, so we see it like this. Battery is for us a part of fuel, and when you compare your fuel consumption with electricity, you compare battery release plus electricity. Okay, and I think this is the right way to say the thing, because when you come back to this question of raw materials for batteries, I think the future is clearly to reuse batteries. And there are a lot of works today in advanced research to how to take a battery 10 years old and turn it into a new one, which is the best way to save lithium and to be on a long way. So I think this is the right way to see things. But as for cars, excluding the entry ticket to enter the market, which was of course huge, it's almost the same. It's even less expensive because when we will get out, when the volume will increase and will be comparable, it will be less expensive because the electrical engine is much simpler and much cheaper than a thermic one.
Pass the microphone to Paul, please. Yeah.
It's very difficult to compare an emerging technology with a technology which has been around for 50 years, you know, and which has been produced in large quantities, large volumes. So the cost of an electric vehicle, including the battery today, doesn't mean much. If you remember in 1997 when Toyota launched their hybrid, you know, everyone was saying they were losing money on each vehicle they were selling, right? And today, you know, everyone is making hybrid electric vehicles. So as far as batteries are concerned, you know, that's one of the issues actually. What will be the cost of the battery in 20 years' time? As far as I'm concerned, I've been working in the battery business for about 20 years in the past, in a previous life actually. And what I can say is never ever in the past so much money had been invested in batteries. So since the automakers are themselves directly involved in the battery research, in reducing cost on batteries, increasing performances of batteries, well, we can expect a strong breakthrough in the future. But I know to make breakthrough in battery takes a lot of time because a battery is a very sensitive equilibrium, you know, and between battery duration in terms of life, battery performance, battery safety, battery cost, and so on. But I believe, you know, the automakers, with all the money they're putting in batteries today, they should be able to succeed, you know.
Well, we hope so. Don't forget that the automobile industry is in the business to make internal combustion engines, and they're being pressurized, as Willie said, and others on CO2. So I'm a little more skeptical about the amount of money that car companies may be spending on batteries. Maybe I'm way off base, but there are so many pressures on the vehicle industry via politics, and the R&D budgets are being stretched so far. I think when you're talking about something that's outside the competence of the auto industry, the battery guys better belly up to the bar and find out, can they really change batteries significantly from the turn of the 19th and 20th, turn of the 20th century to make them do what we need them to do. One quick question. We did start a little bit late, so I'm going to take you just 5 more minutes over, and then I want to have 2 wrap-up comments. Politics, what I call polytex. There's politics and there's technology. Now we're blending our alternative fuel strategy here with polytex. What do you guys think about this, the current clean power for transport? Is this going to be a game changer that the European Commission is trying to drive the market forward? Do you have any confidence that this will be a game changer? Is it going to be business as usual? Don't we need the government? Just give me a little quick reaction. I want to go this way about the European Commission and Parliament's opportunities to help incentivize this all the way along.
It's one of many pressures on the industry, and it will contribute to the whole move in that direction. But I don't think it in itself is a game changer, no.
I have to agree with what Paul says.
No, what I could say very quickly is that we need the support from governments and commission in terms of incentives for, I think, still 4 or 5 years. To leave the EV cars or the green mobility in the room of IC mobility. After, there will be no limit. The products are so comfortable and so desirable on a customer point of view that the customer will take the lead after.
Okay, well, that's very confidently spoken that these vehicles will sell themselves, and I hope you're right. My experience has been a little bit different, that you really have to pull the customer along and convince them hardly. And, you know, the front-end customers that I've seen, the people on the bell-shaped curve, the innovators on that far end, they're rich and they're environmentally oriented. If you're going to make this successful, we've got to make this electric car as close as possible in price to a petrol and diesel car. Otherwise, the average person in this economy and in future economic times where they're very challenged, high taxes, et cetera, unless we get that price down and that cost differential of the barrel of oil goes up to something that, you know, Willie, we're talking about, it's going to be a long struggle. And so there's time, and then there's vision. And I just want to leave you with two thoughts. In 1880, there was a geopolitician in the United States, whose name I don't recall at the moment. However, he made a prediction and a calculation based upon all the horse-drawn carriages that were being used and were beginning to proliferate in society for all kinds of applications. This clever geopolitician did sort of an arithmetic calculation and said by 1920, the United States would be neck deep in horse manure. And then came along auto and diesel. And it was a game-changing technology, and that changed the world. And in fact, by the way, the first engine was running on natural gas. It was on town gas made from coal. Of course, you couldn't put that in a can, so that technology fell into the chasm of commercialization. And so too did the first Ford vehicle running on electricity. So it began that way, and now we're coming around full circle. So, okay, so game changers, if we can get a game changer in material that is not affected, that we have access to the materials, and that the Chinese don't keep all of it, then maybe we'll have those things that will propel these vehicles to the vision that you have. And I just want to leave the final thought is that the future is a very, very big place, and it's going to take a long time to get there. Thank you, ladies and gentlemen, and go enjoy the break in the last section.